and we are going to talk about relative motion today. Actually, if you can't understand the content we taught yesterday, last lesson is totally fine. You just remember the results. So then one of them is tangent theta times tangent alpha is equal to 1 over n, something like that. So first of we go on to talk about the relative motion. This is the last part in the kinematics. That means the last part, the last chapter in the study of motion. So for relative motion, so this is we are talking about the motion of an object relative to another. So you may wonder why we need to study the motion of an object relative to another, because sometimes it will give you a more it can help your calculation easier. Just like if the two objects is chasing each other, if you consider the motion of one object relative to another object, that means you consider another object being at rest. Then the motion seems easier because you're not going to deal with the motion of two objects. You're just dealing with the motion of one object only. Now, first of all, let's take a look at the formulas that we need for this chapter. Now, in most of the case, we will draw the xy axis. So this is object. Now you can see that there's two axes here. So two sets of coordinate system. Coordinate axis or coordinate system. Yeah. So y prime, now you may consider the y is, let's say, the xy coordinate. So this is just the ground. And y prime x prime is just like a car. So there's two observer or just two men. One is standing on the ground, one is sitting inside a car. And they're observing the object. Maybe you're talking about observing another object inside the car or outside the car. It doesn't matter whether the object is inside or outside the car. Let's say if the car is moving, okay? Let's say the car is moving. Now, if this object is moving together with this car, so to this man, to the man A, he will describe that this object is moving at velocity v. But if you're observing in a car, inside a car, you say that the object is at rest, is it? So different observers or different people will give different description of the motion of this object. If they are in different, we call it the reference frames. So we have defined some term first, okay? So reference frame, mathematically speaking, it is a coordinate system. Coordinate that you take the measurement. If you take the measurement on the ground, then the ground will be the coordinate system. If you take the measurement in the car, then the car will be the coordinate. Maybe it will be a bit difficult to understand here. Now let me describe it like this. So this is x prime. So this is x. Just consider it in 1D. So if the object is moving together with the car, so if you're talking about the man A, just a second. Now if the object is moving together with the car, and you say that the x prime is constant, it does not change. So that means the distance between the ball and the man B is constant. But the x will increasing, is it? The x will keep increasing. This is just one example. And then in reality, we are describing the motion in 3D or 2D. Just let this point to be A lah, this is point B lah. A is the observer or the man A, this point. So when he measures the distance, okay, then the x prime is this horizontal distance from the man A. So x prime is the horizontal distance from the man B. Okay, in the drawing we will like this. So this is x. So this is x prime. Okay. So let's say this ball, and we call it the object C. Object C. Now, if we are talking about the position, So I will draw 3 vectors here. I'll draw 3 vectors here. So this is a vector. This is another vector. So this is another vector. Now we'll say that for the position, if you measure the position of object C from A, so this is a position of C relative to A. Then this will equal to the vector from A, the position of B relative to A plus the position of C relative to B. I think you may find it confusing right now already. Now, in terms of a vector, if you still remember how do we add a vector? Is it the vector AC equals to the vector AB plus vector BC? Do you still remember this one? So vector AC I just write as the RCA. So this is the position of C relative to A. That means this is a vector pointing from A to C. And then this is a vector AB. This is a vector BC. Actually, it's just the same as this formula, but we just have we use different notation. Do you have any questions here? If you can't understand this point, then we can't move on here. Now let me know if you find any questions. So then let's move on. Now you know the object will not be at rest all the time, so it will keep moving. So then we have the term of velocity. Now what I will do is I just divide the whole equation with time. So you divide this equation with time. So what will I get is the velocity of c relative to a. This equation is really very important. We are always doing with using this formula to deal with some questions. We are doing some exercise together right now. You just divide by time, and to be more, let me explain it a bit. Now, first of all, this is just a position. You can get the change in position, and then you get something, the formula like this one. You know, change in position, it means a displacement. And then if you divide the equation with respect to time, then the change in displacement divided by time, you get the velocity. So therefore, we get this formula. But make sure that you understand what these quantities mean. So this is the velocity of c relative to a. And this is the velocity of b relative to a. And then this is the velocity of c relative to b. Okay? Hold on. So why we need to understand this, why we need to study this part. So let's talk about some transportation. So you know ships travels on water, is it? If the water is moving, then the ship may moving at a higher speed or lower speed. So let's say so the ship is moving on the water, and the water flow to the right. Water flow to the right. So if you also want to move to the right, okay, then it's easy. Even you do not do anything, the ship will still go to the right. But if you want to go to the left, then you need to pay more effort. And the speed of the ship should be larger than the speed of the water, so that you can move to the left. Otherwise, you can never go to the left. So it's some concept about the relative motion here. So actually, and then also another example is aeroplane.有冇串錯字咩呢度？係喎，sorry，I think 我串錯字咩？係，so airplane travel in the air. So let's say if there's some typhoon, you know that in most of the case, the airport will close and they suspend all the flights if it's typhoon number 8. But let me ask you one thing So let's say, I'm not sure if someone of you have been to Australia Now if you take a look at the time for the airplane to move from Hong Kong to Australia and back to Hong Kong, the time will be different. I'm not sure how much different it is. So let me search it. Hong Kong to Australia flight. So Hong Kong to Australia, it takes around 9 hours and 5 minutes. Around 9 hours. So if you are talking about the Australia to Hong Kong, it takes 9 hours and 24 minutes. Do anyone know the difference between why there are some time difference? Anyone?
Is there like wind towards Australia or something?
No. Let's watch a video. I think this video is a bit interesting to you. Oh, sorry, but I think it's in it's in Cantonese. Oh, just go back to here lah. Quite similar lah. If quite similar lah. Then let's go back to this part lah. First of all, this is a 2D diagram, so it shows you how we draw the relative velocity of A relative to B. So why the one formula look like this one? I hope you may just consider this another formula, but actually it's just the same one as what I have derived. So why I say it's the same one? So when you say that the object A is moving at the velocity A, object B is moving at velocity B, most likely you are talking about the object A. You are observing these two objects on the ground. So actually you can write it as VAG. So this is VBG. Okay. And then, so that means for this formula is VAB. So VAB is the speed or the velocity of A relative to B. So it's VAG minus VBG. And if you put this one on the left hand side, it shows you that it will give you the same formula as what I have derived. Okay. And actually this form is not difficult to understand, I think. So you're just saying that the velocity of A relative to B is the velocity of A minus the velocity of B. If these two are all measured on the ground, on the ground. Okay. So now let's take a look at this one. So this is airplane. So the velocity of airplane in the air, or relative to air. So VAG is the velocity of air relative to the ground. So VAG and then this value, so this is the velocity of airplane relative to the ground. But if you want to measure the time of flight of an airplane, then you're using VAG. But if you're talking about the maximum speed of the airplane, you're talking VAA here. Do you understand? Now similar to a ship. Okay. Don't take a look at that example. Now just get some feelings using this simple exercise. Take a look at this one. So what does mean by in the ground frame? So that means, okay, you are a passerby, and you look at the police and the thief chasing each other. So this is 5 meters per second. This is 7 meters per second. Okay, 50 meter. And how can we find the time? So after time t, then the thief will move with the distance 5t, and then the police will move the distance 7t. Okay. So then I think it's not difficult to write down the formula. You say 7t equal to 50 plus 5t. Okay. Then you can solve the time to be 25 seconds. So that's how to find the time in the ground frame. So if looking at the fifth frame, and so what does it mean by looking at the fifth frame? That means you are considering the fifth is at rest. That means you are looking at you are the fifth, okay? You are the fifth, and you're looking at the police. You know the fifth is not first of all we need to find the velocity. So this is the police relative to the fifth. Then it will be 7 minus 5. That is the velocity of the police, and minus the velocity of the fifth. 7 minus 5 give you 2 meters per second. So that means the fifth in the fifth frame, the police is moving towards him at the speed 2 meters per second. Any questions? And then the separation is 50 meters. So that's therefore the time is 25. Now, of course, they will give you the same answer. Or they all give you 25 seconds. Like it seems, they give you the same answer. Okay. Any questions? No.
Wait, sir, I disconnected because of my internet.
Yeah. Then let's move on to the next one. Now this one is a bit more difficult. You don't need to look at the symbol here, but just take a look at the diagram. So the airplane's compass indicator is heading due north. So heading due north, what does it mean? This is the velocity of the airplane relative to the air. Relative to air. And its airspeed indicator shows that it's moving through the air at 240 km per hour. Now, I hope you can understand by looking at the diagram. This is the speed or the velocity of airplane relative to the air. Okay, it's 240 heading north. So let's say there's a wind. Let me ask you one IQ question. If I say there's some wind, if the wind is east wind, so what is the direction of the wind? From west to east or from east to west? In Chinese is 东风啦。No, when they say east wind, okay, that means the wind is coming from the east. It's called okay. There's some language, just some language. Now that is state clearly, okay, from west to east, from west to east, so 100 km per hour. So this is the velocity of air relative to the earth or relative to the ground. So if we're talking about the velocity of the airplane relative to the earth, so what we need to do, we just add these two velocities together. Do you understand? And in the diagram, okay, it shows you here. So this is the velocity of the airplane relative to the ground. It seems it's shifting to the right, or so shifting to the east because of the wind. Yeah. But it's still heading due north. But it will be shifting to the east. due to wind. Okay, and you can easily to find this magnitude, to find the velocity by using the Pythagoras theorem. And you can also very easy to find the angle here. Okay. Okay. And the next question is asking you if you want the airplane to move to the north. So what you should do? If you want the airplane to moving to the north, you want to head to travel due north. So that means you want the velocity of the airplane relative to the earth or relative to the ground due north. Then you can see from this diagram. Then the velocity of the plane relative to the air should not be due north. There's some angle here, okay? And then when they add the speed of the air, so when you add these two vectors together, the resultant vector or the velocity of airplane relative to the ground should due north. Now you need to draw this triangle by yourself, and then you can find that the speed by using Pythagoras theorem easy, is it? And you can also find this angle easily by trigonometry. Understand these two examples? So do you understand these two examples? Let me ask you this question. Do you understand these two examples? Who say no? Which part you don't understand now?
I have a question. Like,
Yep.
can you still use the Pythagoras theorem even when
This,
the velocities are like relative to different things?
no, you're drawing this vector diagram. This is a right angle triangle. This is east and this is north and this right angle here.
But I thought like the one east is relative to ground and the
North
240 is relative to air.
North is also relative to the ground.
But is the so they're all relative to Earth?
Yeah. When you say
Okay.
travel due north, it doesn't mean that the airplane will just keep heading. It doesn't mean that there's like this case, okay? The airplane need to move like this to against the wind.
Okay.
好啦，maybe now we take 5 minutes break first 好嗎？ So a boy wished to swim across a river with parallel banks. Do you know what is meant by banks? As shown in the diagram above. The water current is flowing at 0.2 meters per second. The swimming speed of the boy is 0.4 meters per second. And in which direction should the boy swim as he wishes to take the shortest route? So do you know where is the shortest route?
Straight perpendicular.
Hello? So this is shortest route. So you want to find a time, okay? Or along that which direction he should swim. And you have also find a time. So in this case, so it's quite similar to this one, is it? It's quite similar to this one. Or exactly the same. So if you're drawing 0.4 is the speed of the boy relative to the water. 0.2 is the speed of the water relative to the ground. So you need to add these two velocities together and then the resultant velocity will be the velocity of the boy relative to the ground. So this is VBG, this is VBW, this is VWG, okay? You add these two vectors together, then you get the velocity of the boy right to the ground. So you're finding this angle. I think it's not difficult to find it, is it? Can you see that? So 0.4 times sine theta equals 0.2. And then you can find that the angle theta will be 30 degrees. And how can we find the time? Now for the time, he needs to go to the opposite bank. We are using the VBG, the velocity right to the ground. Now you can either use the Pythagoras theorem. So 0.4 square minus 0.2 square. Or trigonometry as you like 啦 ，tangent 又得 ，cosine theta 又得 as you like 啦嚇。Then you can find the time, okay? I think it doesn't give you the distance, okay? Suppose it's 20 meters here, okay? Then the time will be just 20 divided by this speed. Then you get 57.7 seconds. He was one of my students before. He is studying a PhD in University of Brown. He get a champion in a singing physics Olympiad before. Okay. So take a look at the next question. Sorry, part B. So reach the opposite bank with the shortest time. Now, let me draw the arrow. Let me draw the arrow here. In the part A, this is the velocity of the boy right to the ground. So what if the boy is not heading in this direction? So let's say if the boy is heading somewhere in this direction. So this is the velocity of the boy right to the ground. Then so that means the boy is moving at some angle with the bank. Okay? With some angle with the bank. So how can we find the time? Okay? So how can we find the time? So we need to decompose the motion into two components. We just we just need to take care about the direction of motion in the vertical direction. The vertical motion. We just need to care about the vertical motion. Then for the vertical motion, what you need to do, you need to decompose this vector in the vertical one and horizontal one. So then the time for the object to cross the bank will be to cross the river will just be the time will be the distance is 20 meters divided by the v perpendicular. It's nothing to do with the horizontal velocity. Okay. Do you have any questions here? Just right here. Because 20 meters is vertical, then you need to use the vertical distance divided by the vertical speed. Then you get the time. It's somehow like the projectile motion. Because in projectile motion, you separate the motion in the two directions. vertical and horizontal motions, and they are independent to each other. So to find the time, you just focus on vertical motion. Okay. Not yet, not yet. I didn't say that how to make it to travel at the shortest time. So how to travel a shortest time? So that means we need the vertical component to be largest, is it? So how can make it be largest? Like you are adding the VBG and WG, sorry, VBW. This is VBW and VWG together. Using the parallelogram rule to find the sum. I think it will be easier to show it. So how can you make the perpendicular component be largest? Can you draw the arrow? Should the VBG in this direction or in this direction or in this direction? Which one? It should be this one, no, right? Because when you add these two vectors together, the vertical component will will just be the vertical component of the VBW. So you need the VBW to be perpendicular, then it will give you the largest perpendicular component. So and then in that case, the time will just be 20 divided by 0.4. It give you 50 seconds. 50 seconds. Okay. Now this is the question type 1. Type 1. You need to really remember how to do it. I think this question is simple enough. Is it? There are just few different types relative motion that you need to know. Now, let's take a look at the next one. The two objects moving at constant velocity in the direction shown. So find the magnitude of the velocity of y relative to x. It doesn't matter when the time is. The magnitude of the velocity is always constant because they have the constant velocity. The velocity of y relative to x is just v velocity of y minus the velocity of x. Is it? So how can we do it? So velocity of y is upwards with the magnitude 3, and then minus the velocity of x, that is 4 horizontal to the right. So hope you still remember how do we add the vector together. So it should be some vector in this direction. Okay. Any questions?
How do you get 5?
Pythagoras theorem. 3 and 4 right angle to each other.
Oh, okay.
Is it? And let's talk about a bit more on the meaning of this velocity. So if you are talking about relative to x, So that means you are looking at the motion from the view of x. Relative to x, it means that you consider x to be at rest. Why? Because if you're looking at yourself, do you think that yourself is moving? You measure the distance from you to yourself, it will just being zero all the time. You will just consider yourself to be at rest. Now, even if you're running on the ground, in your reference frame, in your frame, relative to you, okay? The velocity of u relative to you will still be zero. We're not talking about the velocity of u relative to the ground. We're talking about the velocity of u relative to u. So you just consider x to be at rest. And y is moving at this velocity relative to x. Some velocity 5 somewhere here. So in the view of x, y will just moving along a straight line with constant velocity. Okay. Any questions here? That's why we need to study this topic. Because if you consider the motion of these two objects together, or this one is moving here, okay, to here after some time. So this one is moving to here after some time. The motion is so complicated, is it? If you are looking at the motion of only one object, then it will be much more easier. So can you indicate the point where x and y are closest to each other? Can you draw it on the screen? Now x is a vector, y is moving along a straight line. So at which point they are closest to each other? Do you understand why this point is the closest to each other? So this point is the shortest distance. Do you understand? Do you all understand? So this is the shortest distance. Let me start the poll again. Then I assume you understand now then let's take a question, okay? We are going to find the shortest distance. Find the shortest distance from between x and y. And find the corresponding time. So how can we find it? You can see there is a right angle. And also you see that, okay, for this triangle, you have one side. So that means you need one angle. Now, if this angle is theta, then this one is also theta, is it? Then the shortest distance will be just 8 times cosine theta. Then the problem is how to find the theta. So what does the theta mean? The theta is angle of the relative velocity to horizontal. To vertical. So this is angle theta. Oh, Kenji, what is the value of cosine theta? Kenji，係幾多啊？cosine theta
4/5
Yeah, 405 lah, mate. Then you get the final answer to be 4.6 meter. Okay. Another thing is, how can we find the corresponding time? So you know they are all moving at constant velocity. So what you need to do is just using some distance divided by the velocity. Then you can get the time. And the problem is, which distance should we take? Should we take the d? No. There's no object is really moving along this red line. So actually, what distance should we take? It's the distance here, here, here. This one. So this is a distance moving by y relative to x. Then we are going to find a time from the starting point to here. That's the time when they are closest to each other, is it? And then how can we find the orange distance? We're so silent. Maybe it will be 8 times sine theta, is it? Then divide by the velocity. The velocity is 5. So sine theta, looking from the diagram, is 3/5. Okay. Then it's around 1 second, is it? It's around 1 second. 24 divided by 25. Then that's the answer. So any questions?
Wait, so for the vector diagram,
Yeah. Wait, no one noticed this one, yeah? I feel for the answer are all wrong. Hey. Eh? Why can't you get it correct? Sorry, just the diagram is wrong. But the answer is still correct. Sorry. I think 唔係喎，喂，you fake me 喎，4 3啊嘛，this is and this is 3 okay, this is 4，唉，it's 4.8 meter and this is 32 divided by 25. Okay. Any questions here? This is really a common questions in the commission. You really need to get used to it. Alright, let's move on to the next one. What is this question? Okay. This is a really funny question. This is really a funny question. So the train is moving to the east, and the raindrop that is falling vertically with respect to the earth make the trace that is inclined 30 degrees to the vertical. Do you know what does it mean? Sometimes if you look at the window on the left hand side or on the right hand side of the car, so sometimes the raindrop will be moving at some angle with the vertical. So, and by looking at this angle, we can somehow know the speed of the car. That's what it's talking about in this question. Oh. We don't look at this question first, okay? So what does this 30 degree mean? Now, it's looking from the window. So actually, that means this is the velocity of the raindrop relative to the train, is it? Because you're looking at it from the train, and then it's inclined 30 degrees to vertical. So this is velocity, it's 30 degrees somewhere here. This is the velocity of the train relative to the ground. So this is the velocity of the rain relative to the train. And let's say if we want to find the velocity of the rain relative to the ground. So what are the relationship between these three quantities? How we can relate these three quantities together? Hello?
RT plus T.
You add these two together, then you equal to the VRG. Now how can I think about it quicker? Now you can RT啦, TG啦, you add these two together, you can cancel out the T. Only RG left. So you should add these two together, then you get RG. Okay. Right. Now then if you draw a diagram, then the VTG should towards east, that means in this way. So this is the VRT. Then you know the ring is falling vertically downwards. So this is a ring relative, the velocity of ring relative to the ground. So the entire diagram look like this one. Okay. Any questions here? No? Yes, no, no. I don't do this question. I don't do this question. I would like to go back to the exercise book I've given you the 100 more pages the 100 pages exercise. Let me see. Sorry, relative motion is 1.3 something. 1.3 something. You go to 1.3 something. Now I will let some exercise for you to do at home, just like these exercises. These are not difficult. So you just need to think about whether it's plus or minus, which one add which one, or which one minus which one. And then this exercise is easy. So you finish the page 36 by tomorrow. By tomorrow. Just 4 MCs by tomorrow. Eh? What I want to do? I forget what I want to do. Sorry, I want to go back to take a look at some of the questions I made it by myself.
What book is it again?
Sorry?
What's the book?
I'll send you later on. You get the hard copy already. I'll send a soft copy to you after this lesson. Let's take a look at.
Mr. Yan，我係冇個 hard copy 嘅，因為我冇返。
Okay, I send you a soft copy I can't give you a hard copy 㗎啦，係。 Why what do you mean why? Let's take a look at the question 8. This one. Wongs, okay, you know.
Found it. Never mind.
Now this 2 meters per second is the question we have done, if you still remember. So 3 meter and then 2 meter, and then the resultant one is vertical, and then in this direction it can move with the shortest possible distance. But we are not I want you to think about this one, 4 meters per second. Now let me copy this one to a whiteboard. To the Word file. I think I didn't write anything on the Word file. Now we have done this one already, if you want me to do it, okay, I'll just show you the answers here. Now 3 meter, some angle to the vertical, and 2 meters per second is the speed of the water. And you would like the resultant velocity, or the velocity of the boat relative to ground is vertical. So I think you are talking about the question is asking you about this angle. So it will just be arc sine 2/3. Okay, done. So for part two, do you want to think about this question by yourself first? Now, do you think this triangle is possible? Do you think this triangle is possible? Hello? 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 Do you think it's possible? No, lor. If the answer is no, that means the boat cannot move vertically to the bank. So let's say this is a river. So the boat can never, if the water speed is 4 meters per second, the boat cannot just cross the river vertically. Okay. So because the water speed is larger than the speed of the boat, so it will still shift a bit, and then you are going to find the angle such that it can move at covering the shortest possible distance. We still need to draw the graph and to see at which angle. Now this question is pretty classic, and I hope you can understand. Now we are just doing this question by drawing the graph. Now first of all, you need to know that, okay, we are adding the velocity of the boat relative to water, and also the velocity of the water relative to the ground to get the velocity of the boat relative to the ground. So what we want is this velocity to be angle. It has the smallest angle with the vertical. Is it? If it has the smallest angle with the vertical, so consider these two vectors, and then this one will travel at the shortest distance. This one will travel at a longer distance. Understand? I think it's not difficult to understand, right? So then the problem is, how can we draw, or how can we find this angle? Now this one, if you're talking about the magnitude, both of them are known. If we're talking about the direction, we know this one, we know this direction, and we want to find this direction. And we somehow we know this direction because we want it to be smallest. So we would like to draw a diagram. I will draw the VWG first. Yeah. Now VWG is longer than VBW 嘅吓. This is with the magnitude 4. Okay. Now we don't know at what angle will be should the VBW be then I draw the VBW in all angles. Okay. In all angles. So that means actually you can draw a semicircle here, is it? You can draw a semicircle here. And then let me show you. So the red arrows are the resultant velocities. Can you see it? By adding different by adding different green angles. By adding different green arrows, you get different red arrows at different directions. You want to find the one with the smallest angle to the vertical. So this is the angle to the vertical. Can you find out which one? Is it this one? Obviously, no. Is it this one? No. So it somehow actually is also related to perpendicular. Hold on, let me show. So it will be the one. I still draw a rectangle as a semicircle here. It should be the one vector which is tangent to this semicircle. This one will has the smallest angle with the vertical. Can you see it? Because let's say this one, it has a larger angle with the vertical. Is it? Okay, can you see it? In this case, this angle, this one is right angle. This is the right angle. This is the right angle. Just draw a diagram, okay? Just draw a diagram. Hold on, this is the right angle. So we are choosing this vector. And if you want to find the angle, so let's say this one, this is also theta, yeah, this is theta, then that one is also theta. And let's say if you want to find a theta, then you, the black arrow has a magnitude 4. The blue arrow has a magnitude 2. Then you just use cosine theta. So cosine theta will be 2/4, 1/2. Or the angle is 60 degrees. So that means the boat should cross the river at 60 degrees to the bank. I know this is really tricky. But if you draw it by yourself, I hope you can see it. Like you really need to try to draw it by yourself, because there's some other question is quite similar to this one. If you draw it, then you can do it very easy by just the drawing. Any questions here? Any questions here? No? Well, it's almost 10 p.m.